So just to orient ourselves before we dive in to our discussion, if we're looking at mass-based plan pathways that are available to states under the Clean Power Plan, whether to cover new sources is a threshold question. So as everyone's familiar with, the Clean Power Plan applies to existing sources, but states have the option to include new sources in a mass-based plan if they choose to do so. And alternatively, a state may cover existing sources only in a mass-based plan, and then there's an additional requirement to address the risk of leakage to new sources, or in other words, the incentive to shift generation and emissions to units that are outside of the regulatory system. Before we jump in, I want to preface this discussion by saying that this topic of whether to include new sources in a mass-based plan is something that we've heard come up most often in this context of the requirement to address the risk of leakage to new sources. And we'll talk about the leakage requirement in the second half of our discussion today. But we're going to approach the choice of excluding new sources, including or excluding new sources from a mass-based plan more broadly. And we'll touch on additional factors that might play into that decision, including potential implications for power markets and for load growth. So with that in mind, here's our agenda. We'll first talk about considerations for mass-based plans that cover new sources, and that will include a discussion of implications for load growth and the emissions trajectory, as well as the fact that covering new sources sends a consistent economic signal to new and existing sources with similar emissions profiles. And then in the second half of the discussion, we'll turn to the alternative of covering existing sources only, talk a little bit about that leakage requirement and potential implications for electricity markets. So turning first to the option to cover new sources. You'll recall that the EPA has provided any state that chooses to cover new sources in a mass-based plan with an additional budget of emissions allowances, which they're calling the new source complement. And that's a presumptively approvable amount of allowances that a state could add to the overall budget if they choose to cover new sources. And of course, states can propose their own new source complement subject to EPA approval. One of the first things you'll notice about the new source complements is that they represent, one of the first things I noticed about the new source complements is that they represent a small percentage of a state's overall emissions budget. So if you look at the table on the bottom right-hand corner of the screen, you'll see that if we were to add up all of the new source complements, assuming that every state took a mass-based plan with a new source complement, those extra allowances add up to less than a 2% increase during the interim compliance period, and just a 2.5% increase in the final compliance period in terms of the additional allowances that they add to the budget. And the bar graph, as an example, shows a similar story for each of the states in the Southeast. So the blue bars are the existing source mass-based goals in the final compliance period, and the new source complements are those red stripes at the top. So the new source complements look small, but the thing to notice here is that if you dive into the math behind the mass-based budgets, most of the assumed growth is already built into the existing source budget. So the new source complements represent additional growth beyond that that's already included in the existing source-only budgets. We're not going to walk through that math today, but we do walk through it in the paper that I mentioned, and we can answer questions if folks have them. But I'm now going to turn it over to Dave to talk about how we might compare the compliance obligation covering new sources with covering existing sources only, keeping in mind that much of that growth is built into the existing source budget. Dave?
So thank you, Sarah. So when comparing a state plan that covers new sources with a state plan that covers only existing sources, key consideration is obviously the cost of compliance. Covering new sources could actually reduce the cost of compliance because of the additional allowances available, or it could increase the cost of compliance because of the additional sources that are covered under the mass-based cap. And whether covering new sources makes compliance easier or harder is not a simple question, and it depends to a large degree on future expectations for load growth and emissions trajectory. One potential way to compare the two options is to compare total system costs with and without the new source complement, presumably using modeling of the electricity sector. And modeling results are, of course, driven by model inputs and assumptions. Thus, modeling assumptions about load growth and resource costs, for example, the cost of renewable generation relative to the cost of natural gas generation, will likely be a major driver of the model outputs. I would also like to mention and just remind folks that covering new sources does not limit load growth, it limits emissions, and potentially the emissions that would be likely to meet future load growth, depending on a variety of factors. So next slide, please, Sarah. So turning to the issue of load growth, over the past decade, at a national average level, load growth across the country has been quite low. So using Energy Information Administration data, I calculated the national annual growth rate in electricity sales from 2004 to 2014 as 0.3% per year, so a 0.3% growth rate on average. If we expand that time frame to 2001 to 2014, the growth rate was 0.7% on average. If you dive into the math of the new source complement, you see that EPA uses the load growth assumptions from the most recent annual energy outlook, so the 2015 annual energy outlook. And based on this, they assume a load growth of 0.7% per year in the eastern and western interconnections and 0.9% per year in ERCOT in Texas. And these are obviously higher than the 0.3% annualized growth we've seen nationally over the last decade. So Sarah, please press next again. Turning to a Southeast example, this table shows recent Duke Energy Carolina projections of load prior to energy efficiency, end-use energy efficiency measures, and with end-use energy efficiency measures in integrated resource plans, so 2009, 2012, and 2015. We can see a bit of a trend of a decline over time in the projections, which range from 1.2 to 2% per year. And when we compare that to the actual annualized growth in total generation in the Duke Energy Carolina system, it's high compared to historical, which was about 0.8% per year. This does not mean that going forward their estimates are wrong or high. It does mean that they're high relative to what we have seen in the past. I would also note that utilities generally want to be conservative in these kinds of estimates because they want to make sure they have enough capacity for peak load days going forward. Next slide, please, Sarah. So continuing on the topic of load growth, I personally believe there is significant uncertainty about future load growth. And given this uncertainty, I would keep in mind that there is a potential uncertainty upside in terms of load growth if you take the new source complement, because if you do not build any new natural gas combined cycle units, you still get the extra allowances that come with the new source complement. And over the past decade, there have been a number of states that saw declines in retail electricity sales. So this includes all sales to residential, commercial, and industrial customers. And you can see the list of states here. You could probably add one or two. So it's certainly true that this is not constant across the whole country. There have certainly been states, especially in the Southeast, with increasing load or load increasing at a greater rate than national levels. But there's certainly a plausible scenarios where there really isn't load growth going forward. So given this uncertainty about load growth, my kind of two big picture takeaways, pieces of advice I would have for states are, one, to understand the basis for the load growth projections that are going into any modeling or other data that folks are bringing to you. So for example, ask the utilities to explain their load growth assumption methodologies to you. And secondly, because there is such significant uncertainty about load growth, I would really encourage looking at multiple load growth scenarios, because if you just analyze one set of scenarios for a single load growth assumption, you're really not going to capture the potential range of future demand. But with multiple scenarios, you can capture the plausible range going forward. Next slide, please, Sarah. So emissions can also change based on the resources used to generate and the fuel used by those resources. And again, North Carolina provides a useful example. So what I have here is basically a summary of the entire electricity sector in North Carolina from 2005 to 2014. The top blue line shows all generation from the utility sector, electric utility sector in North Carolina. You can see it's relatively flat from 2005 to 2014. The orange line at the bottom shows natural gas generation from the entire sector. The red line shows coal generation, and then the dashed green line shows North Carolina electricity sector CO2 emissions, so CO2 emissions from the entire sector. And what you see is, while total generation stayed basically flat over 10 years, total emissions declined about 20%. And this is because North Carolina had a fair amount of efficient new natural gas combined cycle generation built. That generation ran a fair amount, and it substituted and reduced coal generation, causing a net drop in emissions. Next slide, please, Sarah. So obviously, and the prior slide demonstrates a real-world example of this, you can reduce your emissions by changing the source of generation. But a key question is, okay, well, what does that actually cost to do? So again, I've got data here from the most recent annual energy outlook. So as part of the annual energy outlook, EIA gives a cost projection for new generation coming online in 2020, and it's on a levelized cost of electricity basis. This shows most of the data from that table. I didn't include some of the higher cost resources. And we can see that natural gas combined cycle units are generally the least cost, as well as wind units. And this is unsubsidized wind. And the minimum, average, and high shows variation regionally. Obviously, wind resources vary, and we do not have the kind of very strong wind resources in the southeast that you might have, say, in the Midwest. But you can see that wind is cost competitive for all the input assumptions that went into this estimate by EIA. Next slide, please. So generation costs from combined cycle units are obviously quite dependent on gas prices. And we are in an environment of quite low gas prices that generally makes natural gas combined cycle generation, including new natural gas combined cycle generation, very cost competitive with pretty much all resources. So this shows the levelized cost for new natural gas combined cycle generation given different assumptions about average fuel prices over the life of the unit, as well as capacity factor. And so for a 75% capacity factor, if we have a fuel price over the life of the unit of $3 per million BTU, the levelized cost drops fairly significantly down to about $37 a megawatt hour. If it's as high as 7.29 pounds per million dollars per MMBTU, the price is about $66, and the 7.29 is the default in the model I use. So I calculated these using the IECM model. It's from Carnegie Mellon. It's available online. Pretty useful and simple tool. And if we're looking at a 50% capacity factor, the costs aren't quite as low, but they're still pretty low, from about $45 to $74 per megawatt hour. And recalling the EIA estimates for wind on the prior slide, they range from about $65, $66 per megawatt hour to about $82 a megawatt hour. So in a very low gas price environment, you're certainly beating the cost estimates that EIA came up with. And I try and make a point of looking at natural gas prices every day. I looked yesterday, and spot prices were well below $2.50 per million BTU, and futures prices were below or near $3 per million BTU through 2020. I don't know what prices are going to be in 2030, and I would not care to make a guess, but we're certainly in a very low-cost environment right now, and according to the futures market, for the next few years as well. So press next, please, Sarah. One thing I would note is that a lot of folks who compare the cost of, say, renewable generation to gas generation and so forth think that EIA's estimates are high. So I've provided an additional source of cost estimates. This is from a 2014 Lazard study that looked at the levelized cost of a variety of different resources. And their estimate for the cost of unsubsidized wind ranges from $37 a megawatt hour to $81 a megawatt hour. So actually fairly cost competitive with low price new gas combined cycle generation. But again, this is, of course, very regionally dependent.
We'll go ahead and turn now to thinking about the alternative of covering existing sources only under a mass-based plan. And as I said earlier, covering existing sources only comes with this additional requirement to address the risk of leakage to new units. And I'll talk more about what that means in just a moment. Then I'll turn it back over to Dave to talk about potential consequences for power markets if the leakage mechanism or mechanisms don't work as expected. So first, I want to quickly review the underlying incentive structure that creates this so-called risk of leakage that state plans must address. So consider a mass-based system that covers existing units and new units. And under a mass-based program that covers both existing and new units, all units face the same requirement to hold one allowance for every ton of emissions. So the existing and new sources face the same regulatory cost, and that cost would be reflected in dispatch decisions. And if we were in a restructured state with a competitive wholesale market, that same cost of the allowance would be reflected in the bids of both existing and new units because they would all face that same requirement. In contrast, in a mass-based plan that covers existing units only, existing units must hold an allowance for every ton of emissions, but new units do not need allowances to operate. So existing units face an additional regulatory cost that new units do not face. So covering existing sources only creates a market incentive to shift generation and emissions to new sources, which don't face that cost of the allowances. And this is the incentive that the EPA is requiring states to address in the mass-based plan that covers existing sources only. So this is the risk of leakage incentive structure that they're referring to. Most of you will recall that EPA gives states 3 options for addressing leakage to new sources. The first option we've already talked about, which is to cover new sources. The second option is to neutralize the incentive to shift generation and emissions to new sources through allocation of allowances. And when the mass-based model rule is finalized, it will include a presumptively approvable option for doing so. As proposed, the presumptively approvable allocation approaches would entail two separate set-asides of allowances. The first would allocate allowances based on updating output-based allocation to existing natural gas combined cycle units. And the idea here is to make the incentive structure for existing units essentially the same as for new units. So this would allocate allowances to existing gas units based on generation. So for every additional megawatt hour of generation above a 50% capacity factor under the proposed rules for this set-aside, the unit would owe more allowances, but it would also earn more allowances. The second set-aside allocates allowances to renewable energy. And the idea here is to create an incentive to meet additional demand with renewables rather than new fossil generation. So in order to monetize those allowances, renewable energy providers would sell the allowances to affected sources that need them for compliance. And this would provide an additional financial incentive for renewable energy. And then lastly, there's a third option, which is for the state to propose another mechanism or set of mechanisms to address leakage or otherwise demonstrate to the EPA that leakage is not an issue because of the specific circumstances of the plan or the state. So turning first to the option of using the presumptively approvable set-asides in the model rule to address leakage. One thing to note here is that adopting the set-asides in the model rule necessarily removes some amount of flexibility in how allowances are distributed. So allowance allocation choices represent a significant public policy decision. Allowances have value, and so those decisions have real distributional consequences. And some of you may have participated in our webinar on allowance distribution a few weeks ago. We won't talk in detail about allowance distribution choices today, but a recording of that webinar will be available soon. If you missed it and you're interested, we'll send out the link. But thinking about the proposed rule and the presumptively approvable set-asides to address leakage, the percentage of the state's total pool of allowances that would be part of those two set-asides, and so the state would be giving up some discretion in determining how that pool of allowances gets distributed, depends on the amount of natural gas capacity in the state. So for all states, the renewable energy set-aside is proposed to be 5% of the allowances in every compliance period. But the updating output-based allocation set-aside for existing gas is set at a fixed number for each state, and that number of allowances for the state depends on the state's amount of existing natural gas combined cycle capacity in the EPA's adjusted baseline. So the total allowances in both of those set-asides combined ranges from 5% for states that had no natural gas combined cycle capacity in that adjusted baseline, so they only have a renewable energy set-aside, to as much as 31% of a state's total pool of allowances on a national basis. And the bar graph here shows the percentage of allowances that would be in those two proposed set-asides for the southeastern states as an example. And for these states, the percentage of total allowances that are part of those two combined set-asides ranges from 5% to 17% of the state's allowance budget. And I should emphasize here that these are proposed set-asides, so the set-asides could change, the rules for the set-asides and the size of the set-asides could change between now and when the model rule is finalized. But if the state adopts the presumptively approvable allocation approach to address leakage, whatever that looks like in its final form, the Clean Power Plan does not establish a forward-going requirement to demonstrate that leakage does not occur, which means that there's no resulting limit on the construction or operation of new sources. And this could be seen as an advantage for a state that expects to significantly expand its fossil capacity. However, there is a potential for power market distortions if the allocation method does not effectively neutralize that incentive that we talked about to shift generation and emissions to new sources. And it's important to note that updating output-based allocation to address leakage has theoretical support. It's been shown to work through modeling, but it's not something that's been rigorously tested in a mass-based emissions trading system in the electricity sector. And we'll come back to that potential for market distortions in just a few slides. Before turning back to those potential market implications, let's touch on that third option to address leakage, which is for the state to propose its own mechanism or mechanisms to address leakage or otherwise demonstrate that leakage is not an issue. The specifics of what EPA might approve are uncertain, and unfortunately I'm not able to shed light on that for you today, but I will share a few ideas that we've heard floated in various contexts, and that's not to endorse any of these ideas, but in the spirit of sharing ideas that we have heard offered as potential things that states might do. And each of these is kind of a variation on an allocation approach. So the first idea that we've heard floated is to use a larger updating output-based allocation set aside for existing natural gas units, or to allocate all allowances through updating output-based allocation. Another idea that we've heard suggested is to use allocation-based incentives for energy efficiency or for renewable energy that reduce demand for fossil generation. For example, through auctioning of allowances and dedicating auction revenue to energy efficiency or renewable energy. And lastly, another idea that we've heard raised is to use contingent updating allocation set aside, to new natural gas combined cycle units, meaning that to use a similar set aside, but that only kicks in if leakage actually occurs. And on a similar vein, I've also heard it suggested that it's possible here that with this option 3, there could be a forward-going requirement to demonstrate that leakage is not occurring, which is unlike if the state uses a presumptively approvable allocation method, which doesn't come with a forward-going requirement to demonstrate that it's actually effectively preventing leakage. Regardless of what EPA deems approvable, as with the presumptively approved set-aside, the extent to which any approved method to address leakage does not, to the extent to which any approved method does not effectively neutralize the incentive to shift generation to new sources, to the extent it doesn't actually work, there is a potential for market distortions, as I've said already, as with in the case of the presumptively approved option. So I'm now going to turn the microphone back over to Dave, and he's going to talk a little bit more about those potential implications for electricity markets.
So thank you, Sarah. As Sarah just explained again, if there is a mass-based state plan that does not cover new sources, it can create electricity market distortions because the new sources outside the cap would not have the regulatory obligation. Conversely, covering new sources maintains a level playing field between existing and new sources with similar emissions profiles. For example, a existing natural gas combined cycle unit and a new natural gas combined cycle unit, because they both must hold allowances to emit CO2 and operate. So if you are only covering existing sources, the impact on electricity markets is going to be dependent, at least in part, on the efficacy of the mechanism to address leakage included in the state plan that are either based on the allowance allocation methods in option 2 or some other mechanisms under option 3. Next slide, please. So in terms of how this could create adverse market outcomes, if you do not cover new sources, if you do not adopt the new source complement, the wholesale market clearing price may not reflect the cost of the policy if new and unregulated natural gas combined cycle units are setting the price. So they would not include the cost of any allowances in their bid because they would not need them to operate, whereas an existing gas unit, an existing coal unit would be including the costs of those allowances in their bid. But there would be no way for them to necessarily recover those costs through the wholesale market. Please press next, please, Sarah. Obviously, this disadvantages owners of existing units and potentially removes their mechanism to recoup the costs of compliance with the regulation through the wholesale market. In certain circumstances, it might also increase the overall cost of operating the electricity system. So you could have situations where you're actually operating higher cost units that would not otherwise operate because of this discrepancy in regulatory costs. And you might also have circumstances where you actually incentivize the construction of new natural gas combined cycle that would otherwise not be needed. So new natural gas combined cycle that would not get built if there was no CO2 policy, or would not get built if the policy covered new and existing units. Wholesale market issues are probably less of an issue in vertically integrated states than in states with regional transmission operators, ISOs, because there might be one utility that owns both the existing unit and the new unit. So they're competing with themselves, and they're also recovering costs through traditional rate making. However, I would note that wholesale markets, although they might not be as active and have as many participants in the Southeast as, say, in PJM, they exist throughout the country. So although this might be less of a concern, it still could create potential issues for certain owners. Next slide, please. There are also implications for emissions integrity. So when we and others did modeling of the proposed rule, it showed lower emissions in scenarios that covered new sources relative to policies that did not cover new sources, largely because of this leakage to new units that were outside of the cap. So I'm not aware of publicly available modeling on the final rule comparing mass with just existing to mass with the new source complement, but it's certainly something to look for. It's something we're going to look at in our modeling of the rule. And again, the actual emissions outcomes are going to depend, at least in part, on the efficacy of the state plan mechanism to address leakage. So if the leakage mechanism, the output-based allocation or other mechanism is working and it is creating a system that creates basically a similar or similar enough economic signal to your existing natural gas combined cycle units as new units, you should have a fairly similar emissions outcome regardless of whether you include new units under the cap. And again, as Sarah stated, once you've received approval from EPA for your mechanism to address leakage and you're implementing it, there's no going forward requirement to demonstrate that it is in fact working and leakage is not occurring. So next slide, please, Sarah. So to wrap things up and to summarize the two options with this threshold level question of whether to include new sources, if you only cover existing sources, there is no limit on new natural gas combined cycle generation. You are required to adequately address the risk of leakage through allowance allocation or other mechanisms. All this is really trying to do is create a level playing field such that your existing gas units face the same or approximately similar economic signals as new units outside the cap, or it's trying to incentivize things like renewable energy that would reduce the use or the need for new fossil generation. But it is not doing anything to prevent you from actually building and operating new gas units. And again, going forward, once you've shown EPA that you've included this mechanism and they approve of it, if it doesn't work, you're essentially okay in terms of compliance and you can continue to operate your new units, basically as much as you need. If you are covering new sources in addition to existing new sources, again, you are not limiting load growth. You are limiting emissions, and in a low gas price environment, you might be limiting the least cost resource to meet that load growth. But there are certainly other options, low carbon options or zero carbon options out there that can be built to meet any load growth. And whether covering new sources makes it easier or harder to comply, it increases costs or decreases costs, is going to depend in terms of modeling of the cost of compliance, both on future assumptions about emissions demand and the resources and subsequent emissions to actually meet that demand. And then in the real world, what is actually realized in terms of load growth and resource additions.